Okay, so tonight we want to start solving these systems of linear equations algebraically. But before we do that, I want to talk about the three different types of solutions you may come up with. Most of the time we're coming up with this ordered pair, an x comma y, and we're saying that's the point of intersection, that's the solution to the system. It doesn't always happen that way. So, let me take that back. So, there are, let's say, three types of solutions, and we'll go through each one of those. The one that we're familiar with is called consistent and independent. Okay, so consistent and independent is what we're looking for most of the time. That's what happens when you have two intersecting lines. And they have this little point of intersection as the xy solution. Okay? So what's interesting when you look at them algebraically, though, you notice that the slopes are different. Let me call it slopes. So slopes are different. So anytime your slopes are different, lines will intersect somewhere, okay? So you'll have this sort of intersecting line. And what's interesting to note in this case is that there is one solution, okay? That's that xy combination. That is the one solution. All right, so that's what happens most of the time. Sometimes it happens where you have consistent but dependent, okay? Let's see. Let's give an example of what this is. This happens when you graph one line. Okay, that looks all good. You come back and you graph the second line and you say, oh, it's right on top of it. It's actually the same line. So you say, oh, okay, that's a coinciding line. They're actually the same line. So of course, any point on this same line will be a solution for both equations. So what you have is same slope, and you also have the same y-intercept, or the same b value. So when that happens, we say it's consistent and dependent. Okay, there is an infinite number of solutions. Anything on that line will be on the other line too, because they're the same line. Okay, and we'll talk later about how you describe the solution. Okay, the third thing that might happen on one of these solutions is you have something that is inconsistent. All right, well, how could there be one more scenario? And that's when you graph the first line, you come back and you graph the second line, and you say, oh, those are parallel lines. They are never going to intersect. So, no intersection, so no solution. There's no point that lies on both those lines. So you have to come back here and say, okay, parallel lines, they have the same slope, different y-intercepts, okay? And there is no solution. Okay, so let me show you, as we're doing algebraically, how these kind of manifest themselves in algebra as well. Okay, let's start to solve these with this method called substitution. And the idea behind substitution is simply to solve for one of the variables. So you solve for x or y, okay, and then do a substitution. Then substitute it into the other equation. So let me show you how that means. The nice thing here on this first problem that I've written out for you is that I've already got y solved for. Okay, so I have an expression for y. So I'm going to use that. And I'm going to take this expression here as a substitution for the letter y in the other equation. So it's going to go here for that y. So let's take this equation right here, rewrite it, 2x plus substitution for y is x minus 2. And that's got to equal 4 going back to that original equation. So now I have an equation that has only x. I can solve for x. So I have 3x, minus 2 is equal to 4. Let me add 2 to both sides. X is equal to 2. So that's half my solution. That's really the hardest part. I'm really most of the way there, but I do have to find the y value. Okay, so make sure you find the other one. Okay, so let's go back. The nice thing about substitution is you've got this equation right here to go back to. So I'm going to take this and use it to find the y value. Y is equal to the value of x, 2, minus 2, so y is equal to 0. And that's my solution. Of course, I'm not done until I put it in an ordered pair, 2, 0. So now I found both the x and the y, I put them in an ordered pair, that's my solution. So let me give you one to try. Next page. Okay, I want you to try this equation. Now remember, the first step is to solve for either x or y. And in this particular problem, it doesn't really matter. But I would choose this x or this y because I don't want to have to be worried about the 5 and the 3 as coefficients. So I'm going to let you pause it, give it a try, and then come back and check your answer. Okay, so here's my answer, 1, 2. I just kicked Brasia out of here. So let me recap this if you didn't get the right answer and you want an explanation, otherwise go on. I looked at this second equation here, and I said I could easily solve that for x. So I took the y to the other side, so x is equal to 3 minus y. Now that I have this, I'm going to use the 3 minus y as a substitution for the other x, okay? So it's going to go in there. So rewriting this first equation with this substitution for x, I just go ahead and solve it, follow my steps, and get y is equal to 2. Once I have y is equal to 2, I'm going to go back to this equation and find x. So x was equal to 3 minus that y value, which was 2, and get x equal 1. Put them together, 1, 2. Solution. So that's the method of substitution. Let's talk about the next method. Okay, now this next method is called elimination, and the idea is to eliminate a variable. Okay, so what happens is if you could come up with match the coefficient in front of an x or y, match the coefficient of x or y. Okay, so like in this case, the y's have matching coefficient, and it's even better because one's negative and one's positive. So the numbers match and they actually have opposite signs. I've matched the coefficients. Then I can add my equations together to eliminate the y in this case. Okay, so I'm going to add the equations together. So I decided these already matched, so let's go ahead and draw an addition line. I'm going to be adding these two equations together. So the 2x plus 4x are like terms, so they make a 6x. The 3y negative and the 3y that's positive cancel each other out. When you add those together, you get 0y, so that's not even there anymore. And on the right-hand side, I add these two things together and get 60. So what do I have is x is equal to 10. So I've found my x, and now I have to go back into either one, doesn't matter which one, either one of the original equations with this substitution for x. So I'm going to do the first one. So 2 times 10 minus 3y is equal to 14. And I can solve for y. Let's see, 6 is equal to 3y, so therefore y is equal to 2. I have my x, I have my y. Together that makes an ordered pair, 10, 2. Okay, so that's my solution using the method of elimination. Now, it's not always kind of pre-matched for you. Okay, if you see that, you're going to say, oh wow, this is a great problem, I can easily do it with elimination. But if they're not pre-matched, then you're going to have to fix them up, okay? And I'll show you how to do that on the next one. Okay, as you can see in this problem, if I were trying to solve this by elimination, I can't simply add the two equations together because neither x or y have matching coefficients, so nothing's going to be eliminated. So what I have to do is figure out which coefficients I want to match. And I'm going to look at this and say, I'm going to try matching the y's, because all I have to do to make them match is to multiply this first one by 4. So if I multiply everything in that equation by 4, it's going to look like this. 8x minus 4y is equal to 20. Okay, so that's the new first equation. The old second equation, or the original, doesn't have to change. So now when I add these two together, I've got 5x, the y's do cancel this time, is equal to 20. I get x is equal to 4, and I found the solution for x, and I just need to go back and solve for y. So let me go back into the original equation. 2 times the x is 4 minus y is equal to 5. I need to solve this for y now, so 8 minus y is equal to 5. Let me subtract 5 from both sides and get 3. Let me add y to both sides and get y is 3. So I get my answer, 4, 3. Alright, I got one for you to try. Okay, go ahead and let you try this problem. You know, in this particular one, I'll give you a little hint if you want it, otherwise give it a pause. You're going to have to change both equations so that you get something that matches. And it works a lot like a common denominator. So let's say I wanted to eliminate the y's. Then what would be a common denominator between 5 and 9? The answer would be 45. So to get to that common kind of coefficient, I need to take the first one times 9, and I need to take the second one times 5. Okay? So that'll be your hint, and try that from here. I'm going to pause it. My answer was a 1, negative 1 as a solution to this system. I can run through it if you need me to, otherwise go to the next slide. When I multiply the first equation by 9, don't forget to do every single term. Okay, so 63x, 45y equals 18. Multiply the second one by 5, okay? All those terms, both sides. When you add the x's together, it's 103. The y's cancel. Add these two numbers together on the right-hand side, you'll also get 103. So x is 1. Once I hit x is 1, I went back to this original equation, used my value for x right there, and just completed that equation. I can go back to the original. I don't have to go back to this sort of hyped up on steroids part of it. Solving, I subtracted 7 on both sides. So 5y is negative 5, so y is negative 1. So that's my combination that works for both equations. The last thing I want to talk about is how the inconsistents look algebraically. Alright, let's say I had an equation that looked like this. I think I'm going to try and solve this with elimination. So I'm looking at this saying, well, if I multiply this guy by 3, the coefficients for x will match. So let me do that. It also does me the added benefit of, you know, removing the fraction, so I like that. So this one becomes 3x minus y is equal to 3, while the original equation is unchanged at minus 3x plus y is equal to 4. So let me add the two sides together, and as I'd hoped, the x terms cancel. Oh, but the y terms are canceling as well. So when you add y minus y, you get 0y. You get zeros everywhere. So 0 on the left, and on the right-hand side I get 7. So the x's and y's both dropped out. I get 0 equals 7, which of course is a false statement, so there's no solution. And if there's no solution, it means those two lines never intersect. They are parallel. This is an inconsistent, don't make me laugh, Bracia. This is an inconsistent system. Alright, so that's it, and we're good to go. We'll see you in class 5.